Carlos, you can start introducing.
Hola, muy buenos días a todos. Muchas gracias por su asistencia y bienvenidos a este espacio que llamamos en Endava Web Stories. Mi nombre es Carlos Tobar, soy el Head of Development en Endava Medellín y nos sentimos muy orgullosos de participar en actividades como estos Web Stories. Esta es una de las estrategias que tiene Endava hace 20 años y como parte de sus pilares que le ayuda a promover el conocimiento y las experiencias de nuestro equipo, haciéndoles disponibles para todos y ayudando básicamente en el crecimiento profesional de las personas que participan. Ahora bien, durante la dinámica vamos a hacer una rifa de 3 boletas para el DevOps Day. Andrés, ¿puedes mostrarnos el QR Code? Este es un evento que se realizará el 30 y el 31 de julio, ¿cierto? Y la idea es que vamos a rifar 3 boletas a los participantes en este webinar. La idea es que usemos el código que Andrés nos va a presentar en la pantalla para registrarnos. Por favor, diligenciar los datos completos. Y los ganadores los anunciaremos en el correo que se les hará llegar con la grabación del webinar. Entonces, también les recomiendo la sección del área de preguntas. Es un icono que van a ver en su pantalla con un símbolo de interrogación y en ella pueden empezar a digitar sus preguntas en la medida que se les vayan ocurriendo. Entonces, ahí está el QR Code que pueden usar para registrarse y ya pues quedar atentos a la rifa de las 3 boletas. Okay.
Igualmente, perdón Carlos que te interrumpa, vamos también a compartir el link en caso de que no puedan pues como escanear el code a través de la zona de preguntas que tienen a la esquina superior derecha.
Perfecto, gracias Andrés. Now guys, let me introduce you Radu Vunvulea. He's our group head of cloud delivery, and he has a pretty good talk about microservices and how their impact and how to balance their impact in the software development lifecycle. With not further introduction, Radu, the stage is yours.
Hello everybody. Good morning, because I know that it is 9 a.m. your local time. I'm based in Romania, Cluj-Napoca, so it's 5 p.m. This is my last meeting for today. So I'm happy and thank you for the invitation to be able to deliver a session. To tell you the truth, this is the second time when I deliver a session for Medellin, because last year in September I had the great opportunity to visit your beautiful country and city, where I was invited by one of the local universities to deliver also a session. So I would like to introduce myself a little bit. My name is Radu Vunvulea. I started to work with Microsoft Azure 10 years ago in 2010. From that time until now, I've been involved in a lot of different cloud projects, especially on Azure, but also some of them were on AWS. And I have a pretty strong background related to enterprise applications in the healthcare, financial, and car manufacturing industry. And also I invested my time in to participate at different conferences, at different events, and to see how and what is the best way, how you can build a capability, how you can grow people, how you can define different programs. If you want to find more about myself, you can check me on LinkedIn or on Twitter. And also an important thing that might be useful in this context, I'm Microsoft Azure MVP and also Microsoft Regional Director. This means that I'm very close to Microsoft Redmond team from US, providing feedback and supporting them directly or indirectly. My first project where I used microservices was in 2014, and from that time on, I had a lot of projects where I had to design or to fix different issues related to that. Now, on my spare time, I'm a big fan of IoT, so I designed my home solution for IoT home automation, based on ESP8266 chips, so they are very cheap and you can do amazing things with it. Now, what we'll talk today in the next 40-45 minutes, I decided to tackle a pretty sensible topic related to microservices and the confusion that is around them, because even if they are not so new, that we have around 4 or 5 years of experience and we already find good best practices and solving them. The technology evolves so fast, the way how we design, how we architecture solutions are moving so fast forward that a few months ago, most of the solutions were oriented on microservices, and nowadays we are more on serverless, we are more on a blend between serverless and microservices. So deciding how to tackle different things, how to design solution in the best way, it's pretty hard. And I think that learning from mistakes, understanding better the current trends and what other people learn and their mistakes could help us to become better. Now, when I talk about microservices and how I see them, I usually like to compare them as they would be the organs from your own body. Think about the heart or the stomach or your lungs and your brain and so on. Each of them, we could see them if we would do a parallel as microservice, as a small container that can have one main function and also some additional one. What is the most important thing here is one service, one organ without the others wouldn't be able to survive, wouldn't be able to deliver the business value to our project, to our customer, to our product. But also at the same time, if you're talking about disaster recovery and business continuity, you might be able to identify some services as you can identify some organs from your own body that can be shut down for a short period of time, or in some cases, without some of them, you can survive, or the product can go forward, can work without too much hassle, maybe with some small medicines, maybe with a load on other services, but in the end, you can work as close as possible to a normal 100% full business. Now, let's take a look on some statistics to understand what is the current trend and why it's so important to understand in the right way how we can design, how we can build services around microservices architecture, around serverless, and how we can combine them. Think about it, at this moment in time, around 73% of companies are planning to use microservices, and they see them very beneficial for building their own application, their own products, their own internal system, and so on. This means that microservices are here to stay, and we need to understand them as much as possible and to know how to work with them, because in the next 5 or 10 years, at least, we'll need to work with such systems. Second thing, take into account the near 2/3 of the organizational that were surveyed are building some applications at this moment in time around microservices. So we are talking about 46% of them. So it's not only something that will happen in the future, and I'm more than sure that most of you work directly or indirectly on different solutions where microservices were used. So when I started to think about, okay, how I could approach this subject, what is the best way how I could put on the table real problems, real issues that we have in our day-to-day activities, in our day-to-day work hours around microservices, and how we could find solution, I decided to do the following. I decided to go on an approach where we'll take a look on some reports from State of Microservices. This is a great report that was built related on microservices. You can find it for free of use on the link that I'm sharing now. It was built by the software house, and it gathered what was the input, what was the response of around 600 or 700 different people that are working with microservices. And it's pretty interesting how easily we can identify trends, how easily we can identify our real day-to-day problem when we are managing, when we are doing the automation of microservices solutions based on the input, based on the response of other people. So I found this amazing that the same problem that I found on different projects, it's also applicable at worldwide also for other companies and things like that. So let's take a look first of all of the market skills, of course, from the microservices point of view. Now, at this moment in time, if we are taking a look on how does the market look like, you will see that most of the people that are using or are working on microservices solutions has around 1 year experience. Between 1 to 3 years, also you will find this gap. And also what is interesting, that people with more than 5 year experience are very, very few. They're only around 7.5%. This means that this is why we might struggle when we need to design a correct system from the beginning, because it is hard to find people with real experience on more than 1 or 2 different microservices projects. Now, the feedback of the people related to setting up a new project, when you are using, for example, Docker and Kubernetes or any other orchestration solutions based on containerization, it's awesome. So as you can see, more than 55-60% of people give 4 and 5 stars. So they're very happy, they're very excited at the moment in time when they start a new project, a greenfield. Well, we are using microservices. Yeah, we are using state-of-the-art solution. But also at the same time, what is interesting and what is important to know, that at the moment in time when you end up to need to do any kind of maintenance or debugging activities, the level of happiness of the people go down. So we have already a lot of people that are giving 3-star or only 2-star as feedback when they need to do a debug of a microservice solution or need to do operation and maintenance of such a solution. And why? Because the maturity level of the tools that are available on the market, even if it's at the right level, we don't know yet how exactly all the time we need to define the processes, what kind of tools we need to use, or exactly what is the right tool for our needs. Now, let's start with the story, or let's continue with the story, because at least here in Europe, people love stories. And let's have a story where we are talking about a watch manufacturer company. It's a pretty classical one. They are building and they manufacture watches for men and for women. And they're on a pretty classical way of doing business and the way how they serve their customers. Also, at the same time, they don't want to have the counters of the steps, but they want to be able to connect their watches to the phone through a REST API to their backends, where they want to be able to send the updates as close as possible in such a way that the customers, the buyers, will not need to set their time each time when they are going from one location to another, thing like that. They don't have a GPS on their clock, but on their watch, but still through the API they want to do this. And the second thing, they want to collect different telemetric data from some of internal sensors that the watch has. So the requirements are pretty simple, and it's very easily to think about microservices architecture. The most common one, or how I see in general that people are thinking about, basically it's to try to group them based on the functionality that they should serve. For example, you are building a service that would handle the update part, the time update part and is having behind the scene another service that is providing the time, and also you might also do a direct call from here to a third service, an external one, from where you have and you get the time. Things might be a little bit complicated here because you need to calculate what is the latency from the moment when the watch requests the time until you'll be able to send the response, to be able to be as close as possible to the real time. Also, from the telemetric data, you have or you need a data collector service, some transformation, maybe a very basic ETL. After that, you have a data sync where you would push everything. And after you have a telemetric router from where you're storing content, maybe to some databases, maybe some to a data warehouse solution, and so on. And additional to this, you need maybe an access control service and any other things. Well, the solution might look pretty simple. And if you are thinking about this, we are starting from two simple APIs. At this moment in time, we have at least 6 different services. For example, for telemetric data, we have the data collector, data transformation, and the data sync. And also we might have the telemetry router to be able to route the content in the right location. Same thing for being able to update the time. You have the time update and the time provider. And on top of that, you have, of course, the automation side, where you have the infrastructure as code for each different service, and for maybe for other cloud services that you are using as the foundation of the solution. Even if in this case you might say, well, the automation is pretty simple because there are just some small services. Taking into account that for each different service, you will need to do the automation, the scripting that would be able to publish, to prepare the package, to deploy in different environments, and so on. So you would have some things to do. And you need to take into account all these aspects, like what is the size, what is the correct size of the node where your service should run. And this is a very long discussion because based on the recommendation, nobody say that a microservices needs to be equivalent of 1 OP class or 2, or should consume, let's say, 10 megahertz of the CPU, could consume the registry of 16 CPUs. Also the number of instances that you need. What is the type of the service? Do you need a GPU? What kind of CPU and registry do you need? What is the level of complexity that you want to put inside each service? Also, what is the communication protocol and how would you like to communicate between the services? Do you want direct communication? Do you want remote procedure calls? Do you want to have an event or a queue on or an ESB system in the middle of them, internally or externally? And how you handle automation? And what is the level of automation that you want to have? Because if it's a small project, you might not want to have the full automated from day one because you might not have enough resources, enough time, enough money to be able to build the business value to the customer, basically the functionality that is built inside the service itself. So I see everything like a mixer, and basically you need to orchestrate, you need to find the right balance between all of this. Why? To be able to deliver the solution in the right moment in time. For example, if the customer say, I want to deliver the solution in 4 weeks time using a team of 2 developers and half the time of DevOps person, then you need to find the right balance about what is the level of automation, what is the level of different services that you want to use, and what are the third parties you want to include to be able to deliver to the customer the value in his given time budget. And of course, there's the functionality that he needs to be able to go in production and to see the value of it. So the ways of working with microservices is the next thing that I want to tackle. And here, for example, if we are looking on the on the microservices report that I started to share with you, what we will see, the efficient level of work when you're using microservices is very, very high. So we have 4 or 5 stars around more than, or let's say almost 70% of the people provided 4 or 5 star, and this is amazing. Comparison with other approaches, microservices, it has one of the highest. Now, also it stimulates a lot the teamwork. From the teamwork point of view, microservices is allowing us to have 1 or 2 teams or to have sub-teams that are focusing on different functionality without having to do too much integration with others or to have too much overlaps, because as long as you can define the right interfaces between services and how the way they communicate, basically defining the contracts and the channel, from that moment in time, each sub-team or each team that is focusing on a specific service can focus on the time on their service and less on the integration inside the platform and so on. And solving performance issues inside a microservice approach is very easy, or this is what the reports say, even if you need to be very careful with this, because it's very easy to say that if you have a performance issue, well, there's not much thing that I can do, because you just say, I don't want to have free instances of a specific container. You just spin up and specify, okay, I want 5 instances or 15 instances of the same container. So basically what you're doing, you might hide the real issues, the real problem that you have behind the scene. And scalability is not an issue, and it's a good thing, because it's very easily to scale to increase the number of instances, as long as the cluster, let's say the Kubernetes cluster, it is big enough to be able to fetch and to be able to run all the instances of the services that you are spinning up, especially if you are in the cloud. Also, there is another approach where you are not aware in the end how many nodes you have. And this is why I say that it might be a problem from the performance issue and scalability, because it's so easy to scale for the number of instances and the number of nodes that you have inside the cluster, especially when there are 2 different people or 2 different roles that are doing this, that you are hiding the real performance problem that you have, and you just see it at end of the month or end of the quarter that the cost of running the solution went from 1K to 5K or to even 10 or 15K and so on. So microservices boost scalability, boost performance, and also support the teamwork and integration with a small note from the integration point of view. Integration, when you're using microservices between the teams, between different services and functionality, can be done very easily, but can be very challenging at the same time. Why? Because when you are defining a contract between 2 different services, you need to ensure that contract will remain the same. And at the moment in time when you're doing a change, any kind of change of the contract, you can notify the other things and to have a minimal effect on them. And this is why I'm saying that is a challenging. It's not, I didn't see very often solutions where the first version of the contract remain, let's say, 80% the same until the solution went in production. And why? Because maybe we don't invest enough time and we don't have a strong understanding exactly how the services will work, how the services will communicate to be able to do such a thing. Now, let's talk about computation, because computation inside microservices, it's pretty cool because you just scale, and you don't care too much about the resources, or at least people are not very aware of this. And for example, if we are thinking about, okay, where microservices most of the case are deployed, what we see based on the survey, almost half of the people are using AWS as the landing zone for the production environment for solutions that use microservices. Azure is following with 70%, and GCP pretty similar with 70%. And of course, GCP is pretty strong here because they are the father and also the mother of Kubernetes and most of the containerization tools that are on the market and so on. Here is an interesting opportunity that on-premise servers or on-premise data center, around 34% of the people are deploying this solution. And why this is an opportunity? This means, and we should expect that in the next 1 to 3 years, more and more people that are running their solutions on-premise to move fully or partially inside the cloud. Now, talking about the serverless and which kind of serverless solution they are preferring, we can see that Lambda are the most preferred one with 62%, followed by GCP, Azure Function, and also Zate now. Now, how many of them are also using serverless in combination with microservices? And oh yeah, a lot of them. Almost half of the solutions, almost half of the people are using also serverless in combination with microservice approach. And to the question if people are aware of serverless application model, for example, the SAM model that AWS putting on the table and is available, only 26% of the people are aware, and this is a big red flag. And why? Because it's telling us that not too many people are focusing to understand the framework, the best practices, and the way of working, for example, with microservices when you are using AWS. Because what does the SAM model provide to us? It's providing us the framework, a way of working with microservices in a structured way that can ensure us that we wouldn't have too many issues, to have too many problems from the design, from the maintenance and operation side, deploying, debugging, and so on. If you are talking about a pure microservice approach, the reality that I see at this moment in time, that a pure one is not very feasible. I don't think that we will have a full pure microservice approach. It's more a blend between different approaches, and the most common one that we could have, it's between microservices and serverless, and the combination between these two, I think it is a success one, especially nowadays when most of the orchestration solution, like for example, like Kubernetes, is providing us the ability to run also functions and serverless approach inside it. And also, what is interesting, that more and more cloud providers are providing us environments, services where we can run seamless inside for example, inside Azure Functions, our own Docker containers. This means that we can define different containers and decide if we want to run them in a microservice approach or as a function in a serverless approach, of course, as long as that service from design doesn't have a state, because if it has a state, then things might be a little bit complicated. So finding the right balance between microservices and serverless can be a little bit challenging, especially when, for example, you are deciding to build a hybrid solution using both approaches, and you end up with a customer that is challenging you. Okay, you said that you want to use, let's say, for functionality A and B, you want to use serverless approach, and for C, D, and E, you want to use or F, you want to use microservices, and they're challenging you as to provide explanation and why it's better to be a serverless approach, or why it is better to run inside the container and not in a serverless approach. So if you are taking a look on what are the features, what are the main things that we need to take into account, and what are the values that each of these approaches is providing to us, microservices give us a lot of flexibility from the development point of view. It's very easily to develop. from the IDE point of view, we have a lot of tools. It's very easily to test, to run, to build, and so on. It's very easy, and also we have in place mechanisms to do any kind of updates or add new features. It's very scalable. It's very scalable, and it's very easy to specify exactly what is the container that you want to scale up or to scale down, and so on and so on. And it's very resilient, providing us the way how we can face any kind of issues that our service might have. From the serverless point of view, they have a much better scalability as long as you have enough resources, and the warm-up period to scale up from 10 parallel functions are running to 1,000. It's not too much. Also improves flexibility because you run and you pay in most of the cases just what you are consuming. And here is a small thing that you need to take into account. It's not very uncommon nowadays to start with pay as you go on a serverless approach, basically paying for the lambdas that are running and for how long they are running, or for Azure functions. And after a while in production, to decide to go in an approach where you have a reserved environment, where you have dedicated resources. For example, like inside the Kubernetes cluster, let's say that you have 4 different VMs that are serving your function. Here, the twitch is that you need to take into account that even if you are still running in a function approach, you already have a fixed cost that is generated by that cluster that you reserve, and the approach is more close to the microservices one. Now, talking about microservices and when you should use them, when they are more larger and you have things more to do than inside the function, and also in the serverless, especially when you're running as a service inside a cloud provider, you are very limited from how much CPU you can consume, for how long, how much memory, and how much storage you can have. Now, and here, let's take a look on a serverless microservice approach. And if you go on a serverless approach, you have the functions. On the other side, you have the microservices. And here, what is interesting, because it's very easily, when you go from a microservice to a serverless approach, you can identify some functionalities of some function that you can squeeze it in different functions. And this is why it's very hard, or it's challenging to find, okay, this functionality, where should reside? Should be using a microservice approach, or should be using a serverless approach? And this could be pretty challenging, especially what you need to take into account when you have a function approach, a serverless approach, that the latency, if you have call between different functions, that the latency that you accumulate between different calls can have a direct impact on how does your application is working. Now, from the communication point of view, in most of the cases, service-to-service communication is the most common one. So most of the communication goes between service-to-service and also to front-end, basically to the web interface that is serving and so on. And also we have some cases when we have communication with a mobile system or with SSR. Now, and if we go look on a little bit deeper, what are the protocols, what are the ways how microservices communicate between each other? In most of the cases, almost 80% are using direct communication over HTTP, followed by event, remote call procedures, and WebSockets. To tell you the truth, I expected more people to use remote procedure calls than events. And also here, there is another thing that I was amazed. People doesn't use messages, they're using events. And we'll come back a little bit about this topic, but think about that people might not have a strong understanding what does a message mean and what does an event mean. Also, how many of them are using different message brokers? As you can see, 73% are using different message brokers. What does this mean? That from this 43% of events-based communication between services, a part of them could be based on the messages. Now, what kind of message broker is most used in microservices? Most of the cases, it's used RabbitMQ and Kafka, and sometimes you can see NUTS or Redis. From the authorization point of view, what is interesting that from the moment in time when you went through the API that is publicly exposed to the cluster, from that moment in time, there's not any kind of authentication and authorization, and you can just go and do any kind of remote calls and so on. Coming back to the communication part. Now, what you should never have when you're using microservices is synchronous communication, especially waiting for another service, for another container to respond to a request. All the communication should be made asynchronous. How you can do this? You can use HTTP communication /S. You can use events. You can use remote procedure calls. You can use even WebSocket and messages. WebSockets are not very common and are not used too much because they're pretty heavy. And if I would, for example, have the ability to decide if I would go with remote procedure calls or WebSockets, to tell you the truth, I would prefer to go with remote procedure calls versus versus WebSockets. Another thing that we should be aware and we should take into account all the time is if I want or if I need to use HTTPS inside internal communication, or I can go only over HTTP. And if you go over HTTPS, how many certification you will use? You will use only one, or you will use for each service a dedicated certification. Because many times if you are using only one and one of your services is compromised, even if you're going on HTTPS, people could take a look on the packages. If you are using different certification for each service, for each type of service and for each instance, then the internal communication it is secure enough. But the question is, do you need that complexity? Do you really need it? And how much would cost you to have this in place? The second thing that I would like also to tackle here is about message-based communication and event-based communication. And what I would like to take from this session, from this part, is the following. What is the main difference between an event and a message? When we are talking about messages, think about it's like very similar to a command. You don't want, and it's not from the business point of view, you are not allowed to lose that message. If you lose that message somewhere through the wire and you are not aware of this, you have a direct impact on your business. For example, if you're talking about a bank transaction and the message is a transaction that would require to take from your account, let's say $5 because you bought a pizza at the pizza shop at the corner of your building, then that message shouldn't be lost. But also at the same time, we have events, and events in most of the cases are used for acknowledgement or for telemetry data. And from the acknowledgement point of view, if you are losing some of them, then it is not the end of the world. For example, think about you have a dashboard and you see the current status of a command that you trigger as a message, and you see that is 5% processed, 10%, 15, 20, 30, 50, 90, and so on. If one of the acknowledgements are lost, from the end-to-end functionality point of view, there's no impact. Yeah, you might not see on the UI an update, or might lose one or two updates or some telemetric data, but from the high-level point of view, the business will be able to continue as usually without direct impact. Now, let's take a look on the debugging and monitoring. And I don't know how often you are doing a debugging or a monitoring of a cluster, of a Kubernetes cluster, for example. But the output of this report, to tell you the truth, provide me the explanation why in one of the initial slides the people rating of the experience of the debugging and doing the operation support was so low, because in most of the cases, logs are used to be able to do the debugging of the solution, to understand what happened and why things didn't work as expected. Only 25% of them are using metrics, and they're using tracing information to be able to detect that. And only 16% of them are using health checks. And if you are thinking about a classical solution that wouldn't use microservices, you would have the tracing information, you would have metrics, and you will have the health check used in most of the projects. So I would say that we will need to have around 85%, and also of course logs. Or maybe you could have logs even lower from the percent point of view, because you already have the metrics that are and tracing information that are providing you this input. And this is why it is something that shocked me, because, for example, how many people are using logs? It's around 85% on the project, and only logs without anything else, for example, without tracing, metric, health check, and so on, it's around 27%, almost 30% of the people that were surveyed. And this personally, in my case, explained me a lot of things why maintenance and operation, when you are working on microservices solution, can be challenging and can be very, very tricky. Because if you're doing a debugging on maintenance and you're just reading logs and you have a lot of load on the system, where there will be a lot of files and a lot of text that you need to process and need to understand, and do the full tracing of things that happen inside the system between different logs from the endpoint to the database and the way back, based only on logs, it's and can be a nightmare. Now, another thing that logs cannot give us the ability to do in comparison with metrics, KPIs, and tracing information is basically to do any kind of prediction of how we should scale up or scale down the system, and how does the solution looks like. So, for example, from the prediction point of view, we need to have insights and to be able to do traceability, to be able to have a fault tolerance, and to know exactly what is the maximum amount of users that we could serve, or the RPO in a way that we don't have a degradation of services, or it's staying under a specific SLA, how we can monitor them, and so on. And from the scope of the service that should be, it's pretty interesting to find out that I identified, and I see very common, and also on GitHub, on public GitHub, that inside the open source repositories, when I usually take a look to see how people are designing solutions, a lot of services are very small, are very teeny, and many times are more oriented on an OOP classes. So if they are doing a migration, let's say from a monolithic solution or a very fixed one to microservices, the approach is, well, if I have 20 classes that are named service or repository, and then I will just transform them as different services, and this will generate a lot of services behind the scene that during the maintenance and operating team, it will be a nightmare. It's not the same time if you need to do the maintenance and operation for a solution that has 10 or 15 different services, or to have a solution with 100, 200, 300 different types of services, where doing the maintenance, doing the logs, doing the tracing between them can be pretty tricky and can become the worst nightmare. Now, let's talk about auditing. And when we are talking about auditing, what we need to take into account when we are building the audit system for a microservice. We need to know what, when, where, from who, and on what. A great solution for this is Falco. This pretty nice service is giving us the opportunity to identify automatically any kind of abnormality that we have inside our audit data, and basically to generate alerts and raise flags, and somebody can tackle them, maybe somebody from the maintenance or somebody from security, to understand better what happened. From the monitoring point of view, all the time we need to have a strong view and a strong understanding. What is our current health of the system? What are the metrics that we are collecting? How we need to understand them? What are the counters? And what kind of logs we have available, and how we can collect them and analyze them. Grafana and Prometheus, I think that are the most used and one of the most powerful tools that we have now at this on the market at this moment in time. From debugging, we need to take into account what is the status, what is the init, the logs, the container, and the pod, to be able to identify what is the issue with our specific container. And when you're doing debugging, don't forget about ephemeral containers. Basically, you can spin up some containers in a sandbox environment inside your cluster, inside your Kubernetes cluster, for example, to be able to identify exactly what is the root problem that you have inside the service or between different services, without having the influence from some external services or third parties and so on. So when you're talking about debug, what are the steps that you should do to identify why your container is not running? First of all, you need to check if the service exists. You need to do a test to be sure that it's running as expected. You need to see at what are the pods that are bound to the service, because you need to be sure that you are running in the right pod with the right resources. Also, you need to check the label, because there's some times when you realize that you don't have the pod or the service spin up. And also the mapping between the ports of the service and the pod, because you might forget to open or to do the routing from the service to the pod and to some other services or to other pods, and the request might end up or might be blocked by the pod itself. If you are talking at the service level, at the implementation level, well, for that one, you have the shell, you have the IDE, and in most of the IDEs at the application level, you have pretty great and very, very powerful tools that are part of, for example, of Visual Studio or other Java IDEs that can be used with success to be able to do remote debugging or to spin up locally a small environment where you can test in the sandbox the thing that you want to do. Now, let's talk about micro frontends a little bit. And from the people that respond to the survey, only 75, 76 of them are using micro frontends. And when they were asked how they are using them, that's the people that respond in most of the cases are using web for web components, or using a combination with web components and server-side rendering. And why micro frontends are so important? Usually, when we are working on microservice approach, we have the team that is implemented each different service. For example, the payment service, the reporting service, the basket service, and so on. We have an aggregation layer. Maybe we have an API, an API gateway, something like that. And we have the front-end team that needs to integrate, needs to understand all the APIs, needs to stay very close with the contract of the interface and so on. When we have the micro front-end, we are more on an agile culture, on a DevOps culture. And why? The payment team contains the people that are working on the database, the people that are working on the backend, and also some people that are working on the front end. So you have a different team or a sub team that are working on the payment service end to end, on the reporting one end to end, and so on. Now, what is the final thought? And I think that because until now all the time we talk about the reports and the response of the survey, let's as a final thought to take a look on the following statement. What do you think about the future of microservice architecture? 50% of the people said that it will become a standard for complex systems. So it is here to stay. 36% of them say that it will become an industry standard for backend development. This means that around 80%, 85% of them expect that microservices will be used for most of the solutions that are developed now and will be developed in the next few years. So microservices are here to stay, but not alone. Serverless, micro frontend, the way how you need to monitor, you manage the event, you do the automation and the integration part are very, very important to ensure that you are developing a solution in the right way and giving the enough flexibility to the team, especially to the maintenance and operation team, to ensure that the solution will have success. And think about, in the end, you have success as a developer or as an architect if after 5 years' time or 8 years' time, there are people in the company that I work on or in another company that are complaining that they still need to do the operation and to do maintenance to a legacy system that you developed 8 years ago or 10 years ago. Why? Because this means that you had success and your solution stayed in production without having to replace it. Thank you. Thank you very much.
Thank you, Radu, for your presentation. I am going to share my screen with the questions so you can read them and answer them. Can you see my screen?
Yes, we can. So the first question was the following: when you are starting a project with microservices, how do you know when to migrate a monolithic to microservice, or it is necessary to always perform this migration? Well, first of all, when you are starting a project, there are two different cases. Are you starting a greenfield one? This means the architecture you have, there's nothing written, so you are free to design the solution in any way you want. And the second one is when you're starting a migration and maybe some technical lead or somebody from the board already decided that we want to migrate from a monolithic approach that we have on-prem to a microservice approach that might run on-prem or on cloud and so on. In this kind of situation, yes, it is necessary to split the monolithic solution. Now the question is, do you want to split it in a microservice approach or in a combination one, or to keep some of them? And it is very important to know exactly the complexity level and what you want to achieve, because in many cases can be in a hybrid solution where, for example, you are using, for example, Azure Web Apps or Apache server, something like that, for front end or for some part of the system that could help you to spin up and to migrate as fast as possible the current monolithic solution and just split it in some different subsystems, some different components, but also at the same time to keep in mind or to know what are the main pains, what are the biggest challenging, or what are the components that are very, very stressed. And that one might make sense to migrate them as a inside a container, something like that. But nowadays, to tell you the truth, it is so simple to push inside the container almost any kind of code. But what I would highly recommend you to do if you go in a microservice approach, try to go in a microservice approach, and after that to identify which are the components, which are the services that could run in a service approach and things like that. Because when you are adding different architecture approaches, the problem is that the development team, the team that will work on that project, needs to understand different concepts, needs to understand different tools, different kind of tools and ways of doing monitoring, audit, deployment, and so on, that will add extra complexity. So be very careful how many tools, how many systems, how many way of architecture you are designing and you are doing. Could you please explain the difference between an event and a message? I will explain one more time and I will give you a very simple example. Let's say that you have an IoT solution. From the phone, from the user interface, from my phone, I want to trigger an action that would open my garage door. That command that needs to reach the backend system to be able to trigger the engine of the door open, it will be a message, because it's very important to not lose that to not lose that message, to execute something behind the scene. An event can be seen in this case as the acknowledgement that the backend would send to the user interface, to my phone. For example, command received, command was sent to the garage door. Garage door is moving, garage door was opened with success, something like that. These are acknowledgement and can be treated as acknowledgement, meaning that if I lose some of them or even all of them, in the end, my door will be open. Also, all the telemetric data that I'm collecting from these IoT devices are just some events. If, for example, from 10,000 events that are telemetric events, I lose 10 or 15% of them because of some weird causes, I will be able still to generate the high-level reports to understand how long the system was online, what is the latency, and so on. So there's not a direct effect on the business. The third question was the following. Is it imperative to move to microservices, or in some situation a monolithic app is more effective? How to evaluate the moment to migrate if necessary? Well, this is a very tricky question. It's a very good one. Usually these kind of migrations, from what I've seen, or any kind of migrations, is triggered from two different sources. The first one is a decision at leadership level, at the board level of the company. So for example, imagine that you're working for a product company and they decide to do a migration and to move everything from on-prem to cloud, and their high-level architecture, the enterprise architecture, is based on microservices. Well, in that case, all the monolithic solutions will be rewritten using containerization, microservices, and so on. The second thing, it is based on different business values. So, for example, if from the business value and the life cycle of the application, people identify that on long term, it is much better to run inside a microservice approach than to the current monolithic system. And for example, the monolithic system exists for 8 years and running in production for 8 years. The life cycle of the current version is 10 years, and they have two options. Should we rewrite it from scratch using a monolithic approach still, or do we would like to go with a different approaches from where we have more tool support, more easily to scale, and so on. Another thing that might also need to be taken into account when we are talking about the cloud migration from on-premise to cloud, and you have a monolithic system that you need to decide how to do this kind of migration. Should I take it as is and put it inside cloud, or what should I do? Well, depends on the budget, depends on the timeline, and what you would like to achieve. If you want just a migration, the most simple way possible is just to take the infrastructure that you have on-prem, replicate inside the cloud, put the microservice, put the monolithic there, and after that you can analyze exactly what are the biggest pain on the current solution. It is performance, cost, running cost, and so on. And depending on this, you can identify from that monolithic solution what are the components that needs to be rewritten or needs to run in a serverless approach, in a microservice approach, and so on. Thank you.
Thank you, Radu. So, do you hear me?
Yes.
Amazing. So, thank you so much for your time and for sharing your knowledge with us. We would love to do more events with you in the future, and I hope you have a good afternoon in Romania. Thank you so much. So, I am going to switch. Sorry?
Oh, thank you. Thank you for the invitation.
You're welcome. So I'm going to switch to Spanish to say goodbye. So a todas las personas que se conectaron, muchísimas gracias por estar aquí y por creer pues en esta iniciativa de Web Stories, la cual pretende como tal compartir conocimiento y llegarle a la mayor cantidad de personas posibles, no solamente como tal en Colombia, sino ya a nivel LATAM. Esta semana les estaremos compartiendo la grabación y con el resultado de los ganadores de los tickets. Que estén muy bien. Feliz día.
Andy, yo, perdón, te interrumpo antes de terminar. Agrego que veo que al final se pusieron unas preguntitas, las vamos a recopilar y con Radu las miramos para darles respuesta cuando les mandemos la grabación, para que estén pendientes y les enviamos las respuestas. Muchísimas gracias a todos. Feliz día.
Super. Chao.